In our previous videos, if you remember, we took a deep dive into Lexing. That's where we learned about how to take raw code and break it down into individual components, like words in a string of sentence. Now, we are moving to the next crucial step, that is parsing. Parsing is a stage where we take those tokens which we made in Lexing and we convert and we give them some meaning, like structuring them in a way that computers can finally understand and work with it. We are going to talk about infix and postfix notations specifically in the context of parsing expressions. Here we will clearly state that what is infix and what is prefix operation and how we can use them and where we can use them. Let's start by talking about infix operations, infix notations. And this is something you're already familiar with. In fact, infix notations is the way we naturally write our expressions in everyday life. In infix notation, the operator is positioned between the numbers or letters it's operating on. For example, here the plus is inserted between 2 and 3 and so on. It feels very intuitive to us as humans because it directly mirrors how we write our expressions in our everyday life. The order in which the operations are performed is determined by the familiar operation precedence rules that we already know of. For example, board mass. And by using parentheses, we can explicitly mention what we can do. We can change the order of the board mass. While the infix is fantastic for human reliability and understanding, it does introduce a level of complexity when it comes to computers and actually parsing and interpreting it. Parsers designed for infix need to be able to correctly handle the operation precedence and those nested parentheses accurately. Otherwise, there will be some weird errors. Now that was all about infix operations. Now let's shift gears and explore the postfix notation. So in postfix notation, the operators are placed after the numbers or the letters they operate on. We fix the operators after the or post the operands. That's why postfix. When we first look at it, it seems a little different, a bit strange. But let's take a closer look at it and we will find something really interesting emerge. Notice something different immediately. There are no parentheses in postfix. So there is no ambiguity about what order it should follow. That's why postfix notations elegantly eliminate the need of the complex operator precedence rules that we have in infix. To actually evaluate a postfix expression, the standard and most efficient way is to use a stack data structure. It turns out that postfix is straightforward for machines to process and evaluate. Let's quickly solve this example of postfix and evaluate its result. We move from left to right and we use a stack here. So let's go. We first encounter a 4, we push it to our stack. Then we encounter a 2, it's a number. We can push it to our stack. Then we encountered first operator. Now what we do is when we encounter an operator, we pull out this last 2 items and do the operation on that. So 4 into 2 is 8 and we remove this and put our 8 into the stack. Okay, till now we are done. Then we got a 4, it's a number, so we will push it to the stack. We got a 3, we will push it to the stack. We got a multiplication sign again, so we remove these two, we multiply them and we add the result back to the stack. So 4 3s are 12. So we have 12 and 8 to the stack. Then we found a plus sign. What we do is we remove the last two, we perform the operation and we add back the result. So 12 plus 8 is 20. So finally we got is, so when the string is complete and there is only one element in our stack, that means that is our result. So this will evaluate to 20. So we saw the infix and we saw the postfix. Now let's compare the complexities, the parsing complexities of these two. So when it comes to parsing, infix and postfix are on varied level of difficulties for a computer. An infix parser needs to be designed to understand and correctly apply those operator precedences and the associativity rules we already talked about. To handle this complexity, parsers use some sophisticated algorithms. Most common one is a recursive descent parser, which I have used in Coda. These algorithms essentially work to convert the infix operations into an abstract syntax string. We can see an abstract syntax tree or a AST of Python here, which converts multiple statements into this tree. Postfix parsing is significantly simpler for computational perspectives. As we demonstrated with the stack example, a very straightforward stack-based evaluator can directly process and calculate the results of the postfix expression. There is absolutely no need to build in complex precedence rules or worry about handling parentheses during the evaluation phase. It is important to realize that because this parsing difference, infix expressions are often converted into postfix. There is an algorithm for that to convert infix to postfix, or even prefix. It's completely opposite of postfix. Actually, this step actually improves the performance of the machine. We just now saw how postfix is very easy to traverse and is efficient. But why are the programming languages still using infix? So, infix notation is primarily and most universally used for the user-facing expressions. It's fundamentally designed for human readability and ease of writing. It's simply how programmers naturally think and write code while dealing with mathematical and logical operations. The vast majority of programming languages you will encounter use infix notations as the standard way of arithmetic and even logical operations within the code itself. And postfix operations, on the other hand, is very often employed as an internal representation with the inner workings of compiler and interpreter. Postfix shines when we come across efficient machine algorithms or evaluations, especially in the environments like stack-based virtual machine, where processing postfix becomes streamlined. Interestingly, some specialized calculators, particularly older ones, and some even niche programming calculators like Forth, directly expose and utilize postfix notations for the programmers. In a nutshell, infix operations are primarily for humans, while postfix notations are largely for machines. Infix is highly readable and natural for people, but it introduces complexities in parsing for computers. Postfix, on the other hand, is less readable but efficient on the machine. So what's next? Well, in our next video, we would actually dive into practical side of trying to implement a postfix evaluator into a code. And we would do a deep dive into how recursive descent parsers work.